Okay, welcome back to Algo.js. Today's question is LeetCode 90 subsets 2. Given an integer array nums that may contain duplicates, return all possible subsets. The power set, the solution set must not contain duplicate subsets. Return the solution in any order. So in example 1, we have nums array which is equal to 1, 2, 2, and the output contains 6 different arrays containing all the different possibilities of this nums array, excluding duplications. So this is just an addition onto subsets, the original question, but it's a really tricky question, especially when it comes to resolving this duplication conflict. So let's dive into the explanation. Okay, so for this question, we are going to be using DFS, and it is going to be a backtracking solution. And the way I like to do these is to draw out the recursive call stack. So initially, we're going to have a result array, and this is going to be set initially with the empty array because the solution requires an empty array within the results. So we can simply just populate the res array with that, and that solves that issue. So let's draw out the recursive call stack and see what we can come up with. So if we take 1, at this point we have 1 in the current array, right? We need to populate that in the res array. Now what do we have left? Well, we have 2 and 2. So we can either take 2 or we can exclude 2. Because if we take 2 on both sides, this is going to cause a duplication, right? So say we take 2. We have 1, 2 in the current array, and we only have 2 left to traverse to. So we can add 1, 2 into the result array. Now we take 2. We have 1, 2, 2 in the current array, and there is nothing within the array now. So we can add that into the result array. So 1, 2, 2. We carry out our backtracking. So we go up to the previous level. There aren't any other positions to go to. We go up to the previous level. Now with this one, we have a 2 down the other side, but we aren't going to be taking that. So this is a no-go zone. So we go back to the top. Now we take 2. So the current array is going to be 2, and we have 2 left to take. So we can add that into the result array. We take 2 again. In the current array, we now have 2, 2, and we have an empty array to search through. So we can add that into the result array. We have reached the end of that search, so we backtrack. Now we have a direction to go to, so we backtrack again. At the top level, this is where it gets tricky, right? So we've got a 2 here. If we recurse down this, we are going to get the same solutions as here. So we need to avoid that. And the way to avoid that is to compare these two values. Now we don't know initially whether this array that we're initially given, the nums array, is sorted. So we need to sort that to begin with. And then we can simply check if I is equal to I minus 1, so the values are equal to each other. If they are, then we continue. So we move to the next value. So say we had 4 to search to, we'd move straight over to that value. But in this case, we just exit this loop and we return the result array. But this is the general kind of structure of how you'd avoid duplications. So we'd sort the initial array, and then we check the values that are next to each other, whether they're the same. If they are, we just continue through the nums array. So with respect to time complexity on this one, we have 2 branches coming from each recursion, and it's going to be to the power of n, which is the height of the tree. And we need to do that n operations. So that's going to be n times 2 to the power of n. We have this sorted. We have the sorting of the initial array, which is going to be n log n. But this becomes insignificant, seen as the overall time complexity already is n times 2 to the power of n. So we take the largest, and then space is also going to be O n 2 to the power of n because of the recursive call stack that we use within the DFS. So let's write this out. So let's start by creating the result array, and we said we initially populate it with an empty array. That solves this case within the output. Let's create the depth first search function. So when we call depth first search, we're going to have to pass in the nums. So the nums array, we're going to pass in res because we need to populate that. Passing in an empty array, that will be our current array, and we pass in 0. This is going to be the index of the number we're on. So nums res current array, and we'll call the index start. So initially, before we carry this out, we are going to sort the nums array. So let's sort that. And then we have to loop through this array. We're going to take I as the starting index. I is less than nums.length. Now we need to make the check to see whether there are any duplications. So let's start off with if I is equal to start, or nums at I does not equal nums at I minus 1. So if they aren't the same values, so we're going to push into current array nums at I. Then we're going to push into the result current array, and we're going to create a copy of this because we are going to be using current array throughout the recursion. We carry out the recursive call, we pass in the nums array, we pass in res, which we just updated, the current array, and we update the index or the start value to I plus 1. And finally we need to backtrack, so we can simply do current array dot pop. Let's return res and give this a go. Okay, let's submit it. And there you have it.